Welcome to section 1 of unit 5. We're going to be doing both lessons 1 and 2, and we are going to be making some rules, and we're going to learn what a function is. Here we go. We're going to skip ahead a little bit here in lesson 1, and we're going to start with lesson 1, activity 3. Okay, the first thing you need to know about functions is that we're going to start with an input. Something is going to happen. We're going to call that the rule, and we're going to get an output. Okay, notice right now we are on activity 3 in lesson 1. We skipped activity 2 because you'll see that in the practice section later on. For each input-output rule, that's what we're going to call this for right now. We're going to fill in our table, that's this over here, with the outputs that go with a given input. Then you're going to add your own to the table. So here's an example. The first one, your input is 3/4. The rule says to add 1 and then multiply by 4. Well, if I add 1, that's going to be the same as 1 3/4, which is the same as 7/4. And when I multiply that by 4, or 4 over 1, I can simplify before I multiply, and I get an answer of 7. That's what I see over here in the output table. Go ahead and fill in the rest of the output table. Down here, you will add your own inputs. They can be any numbers that you wish. Okay, you can see my work for filling out this table and 2 values that I added on my own. Pause and take a look at this work if you need some extra help with it. Now this rule is kind of goofy. It's just to name the digit in the tens place. Remember, that is the place value right after the decimal. So 3/4 as a decimal is 0.75. So the digit in the tens place is 7. So filling out the rest of this table, I would see that my other answers would be 3 and 0. So put your own in there and then continue on. This one is also a strange rule. The rule is just to write the number 7. So here we go. No matter what my input is, my output is always going to be 7, even if my input is 1 million or just 2. Now here's where we have to remember about dividing by 0. The rule here is to divide 1 by the input. So it looks like this, 1 divided by x, if x is the input. So over here, if my input is 1, I'll just have 1 over 1, which equals 1. But if my input is 0, that would be 1 over 0, or 1 divided by 0. Can't do it. We call that undefined. We cannot divide by 0. Okay, now we're moving on to lesson 2. We're actually on activity 2 in lesson 2. So find that. Now, they give us an example to work through first. A person is 60 inches tall. Do you know their height in feet? So here's 2 different ways you could think about this rule. We're going to start with an input of 60. And we have to convert inches to feet, and we could see that that's going to be the same as 5 feet. Mathematically, what we're doing, the rule is to divide by 12. So our job right now is to figure out what is the rule that we're going to be using. Okay, activity 2 in lesson 2. We're going to first say yes or no for each question, and if it's yes, we're going to draw an input-output diagram. So here we go. A person is 5.5 feet tall. Do you know their height in inches? Yes, we can figure that out. So we would take however many feet tall they are, and in our input-output diagram, we're going to have our rule in the middle. And what do we need to do to figure out inches? Well, we would take however many feet they are, and we would multiply that by 12. Now, just to double check over here, if they start out 5.5 feet tall, we're going to multiply by 12 to convert that to inches. And as I go through my work here, I would end up, decimal is going to go right there. I would end up with 66 inches tall, which, yes, makes sense. So this right here is my input-output diagram. Let's go on to number 2. A number is 5. Do you know its square? Yes, we do. If you don't remember what squaring means, remember it's just taking a number times itself. So we could take whatever our number is, let's call it n, and we could take that number times itself, so n times n, and we would end up with n squared. So there's our input-output diagram. Now number 5. A rectangle has an area of 16 centimeters squared. Do you know its length? Well, no. Length, or area, is found by taking length times width. And I could take 2 different things to get 16. I could do 4 times 4, or I could do 8 times 2. and I don't know for sure which one it is. So no, I don't know the length if the area is 16. The next section in lesson 2 is using function language. And this is going to be where we start writing statements where something is a function of something else. So going back to our example, a person is 60 inches tall. Do you know their height in feet? And we already said that. Yes, we do. And so what that means is that their height in inches is a function of their height in feet. And so we want to be thinking that their height in inches depends on whatever their height in feet is. And so we could also write this as something depends on something else. And maybe that's an easier way to think of it for you. So you can use either one, is a function of or depends on. Okay, so using function language with the statements that we've already looked at with our input-output diagrams. Number 1, since we can do an input-output diagram for this example, we would say that height in inches is a function of height in feet. And number 2, we would say that the square of a number is a function of the number or the original number. And those two work. They are functions because we were able to draw an input-output diagram for them. There is only one possible answer for each of those. Number 5, we would say that the length is not a function of height because we couldn't figure out the length in this example because there was more than one possible answer. Here's a vocab term that you need to write down in your book. A function is a rule that assigns to each allowable input exactly one output, which means in our input-output, there is only one possibility over here that can come out from the rule. So make sure you have that written down.